Okay, let's start the next session, next topic. So next topic is basically ShuffleNet. We are going to discuss about ShuffleNet. But before going through ShuffleNet, let me introduce the group convolution idea. So group convolution is basically the idea is dividing the input tensor into multiple parts, multiple groups, and perform the convolution on that groups separately, and then combine again. So depth-wise convolution is kind of special case of grouped convolutions. In depth-wise convolution, you divide the input tensor into number of channels groups, but in general, in group convolutions, you can divide your input tensor into any number of groups. So in this figure, you can see the input tensor is here, and it's divided into two groups in channel dimension, and you perform the convolution operations. For example, this filter is convolved over this area, and this filter is convolved over this one. And after that, after convolving separately, you just concatenate the output tensors. So this idea is basically proposed in AlexNet. That was because of memory constraints. In 2012, as you know, we didn't have enough GPU memory for this kind of deep learning computations. And since they didn't have enough GPU memory, they wanted to train their AlexNet in 2 GPUs. And they wanted to group the convolution filters into 2 groups. And in this way, they could train the... So this is the AlexNet network structure. So this is the input image. They divided the convolution filters into 2 groups because of memory constraints, and they have done all this feed-forward operations in one GPU, and this is another GPU, and they combine these feature maps at the end, at the last layer. So, of course, they didn't know about grouped convolutions while doing this. They have just well done engineering skills, but after that, so researchers invented grouped convolutions. So by grouping the convolution, for example, if you have 2 groups, you basically decrease the number of operations 2 times. As you may remember, in depth-wise convolution, since we separated each channels into separate channels, separate tensors, we decreased number of operations a lot. For example, if you have 2 groups, you would decrease the operations 2 times. So other than that, there's another advantage, that is learns better representations. Like, for example, this convolution layers would learn something related with this one, not with this one. And this also means the feature relations are sparse, not so dense. But at the same time, it has also disadvantage. That is, for example, features here are only taken from all these feature maps, all these convolution filters. This is the disadvantage. So you cannot propagate this information here. You can only do propagate these informations in this channel, in this group of convolutions. So this is the main disadvantage. So ShuffleNet is about addressing this problem, and what they do is actually, so this is how the group convolutions, and in ShuffleNet they propose to shuffle the channels shuffle the grouped convolutions after each layer. So since right now we don't have any memory constraints, we can do a group convolution in one GPU and make shuffling again and go further to next layers. Yeah, the main side effect was output from a certain channel are only derived from a small fraction of input channels, and the solution is shuffling after each layer. And so, as you guess, in order to train deep neural network, everything you use in your network should be differentiable, right? Because you want to differentiate your loss, differentiate your gradients, and backward to the network. So channel shuffling also differentiable, so that you can train your network. Yeah, you can store the shuffling combinations, and then in this manner you can differentiate the gradients. So this is the main idea of ShuffleNet. So as Dimitri said in implementation, most of networks has units or like modules or small small blocks, and ShuffleNet also has the block. This is the bottleneck layer, named bottleneck layer. So this is the input tensor. They applied 1-by-1 convolution first, and then device 3-by-3 convolution, and again 1-by-1, and just add skip connection here, and this is the output tensor. And this is the another version that is pointwise group convolution. So here they make the group convolution on 1-by-1 convolution layer. So they have like 1-by-1 convolution, and they group this 1-by-1 convolution into, for example, you can do it 2 or 3. What else? Everything is okay, and shuffling the channel and doing the device convolution, and again group convolution here. Yeah, this is the main idea of ShuffleNet. Let me recap. They use pointwise convolution, and they also make the grouped convolution in pointwise convolutions. So in this manner, they use the advantage of group convolution, and also by shuffling the channels, they overcome the main side effect. So this is the main idea in ShuffleNet.